Welcome everyone. This is Nmrg second session of the week. I will circulate the blue sheet. This is a IETF research group meeting. The IETF follows the IETF policy known as the NotWell. And so essentially, this is a reminder of IETF policies in effect on various topics, such as patents or code of conduct. So you have a list of key elements reminded in this slide, and all details are in the best current practices documents and at the different links. So please be aware of that. As for every meeting, we need at least 2 volunteers, 1 for the minute taker and 1 to relay on the Miteco Jabber. And as I always say, we will not start the meeting if we don't have those 2 volunteers. So the sooner we have those, the sooner we start. It's not a big deal. Yes. Yeah. Thanks, Jürgen. So Jürgen will be our Jabber scribe. Anyone willing to take minutes? We have Etherpad. Again, usually it's not a big deal. I also have some minutes for myself, so it can be light. Don't be shy. Will, are you willing to take some minutes?
I'm not sure. That's a potential because I'm not a native speaker and I will rely a lot on the video. I can assist with the notes, but I'm not the main one to catch all the stuff.
Okay, so thanks. We have a half-minute taker person. Someone else to help Will? Please. Yeah? Someone on the dark side of the room? Anyone willing to help for the minute taker? So I will turn to my usual suspects. And there are not so many of them here. But Jérôme, would you like to help a bit, Will, for some part of the minutes?
Yes, you can.
Thank you very much. Blue sheets. So we are circulating the blue sheets since some participants are still coming in. Please remember to make them circulating through the room. This is very important in order to have a right estimation of the number of participants to get the right types of room for the next meetings. And we are very happy to be here in the best meeting room of the hotel, where we have actually first-class citizen here, and I don't know what the people on the left are doing. Anyway, so just a quick recap. So we already had one session during this week in the IETF. The session was dedicated to progress on intent-based networking. I think it was a pretty nice session. A lot of people in the room, very interesting presentation and comments. The next step then for that will be to really build upon those feedback and the energy that we had in order to make it a concrete plan and progress on the documents. Now we are in the second session. This is a bit different. It's a 2-hour session, so we have quite a lot of time to discuss through the different topics. And the general topic of this session is to approach the future of Nmrg. This is something we have started a couple of meetings ago, also on the mailing list and through virtual meetings. So I asked some participants to provide some inputs to the discussion on various things. To help a bit to trigger discussion and feedback, and I will have also some slide at the end to give some general information on the research group, but also try to capture where we are going, and I mean put some deadlines and some concrete actions on that. So this is the main topic of today. So the agenda is very simple. This is my introduction, which will end in 1 minute. We have a, so thank you. Forgot to mention a very important anniversary. Nmrg is 20 years old this year, this month, more or less, with the official creation. So I think it's the oldest research group active in the IETF. As I usually say, I don't know if it's a good thing or a bad thing, but we are here. We have also the luck and the pleasure to have at least one of the previous Nmrg chair in the room. Our goal was to have the two other previous Nmrg chair with us, but unfortunately they could not attend, and I'm not even sure they will be able to attend remotely due to difference in time zone and other commitments. But still, what we have discussed together is to put a short retrospective of the different things the research group have studied in these years, and that could maybe trigger a reflection on what we have done, what should we do for the future. So don't look into more than that in this presentation, but I think it was important to make a point. Then we have our second topic as input for the discussion, the use of AI techniques for network management. So this is a kind of collective input based on several participants that provided their views and some reflection on different aspects that would be useful for the group to study on AI for network management. This is a very open topic. I think a good outcome of the discussion will be to have a better understanding of what's the positioning for AI and network management with respect to each other, and in which directions, what kind of studies the research group can really invest on in this topic. I think we already had some session in the past and discussion on this topic, but I think we have not concluded, and so this is a new attempt to move forward on this. And then discussion on the future of the research group, as I say, go to some conclusion, discussion on that, and some information on the research group. So now it will be the other presentation. And Jürgen will start for the period he has covered in the research group, and I will take over for the second phase.
So welcome, right side, left side. Some 20 years ago, I was guilty of writing a charter proposal for a research group, which I call the Network Management Research Group. And it's kind of funny that it still exists and that I'm here and you talk about the future of it. And that's even more funny. So the slide lists the number of the chairs that have been chairing this over time. So probably go to the next slide.
You want to click or?
Oh, you can click for me.
Okay, good.
So how do you measure what a working group or research group does? Well, you count as result produced. Yeah, so count the number of RFCs. So there are 8 RFCs published that really came out of the research group over time. Now, if you would say 8 over 20 years, that's probably not a huge number, but at least we managed 8. We did much better in terms of number of meetings. So 51 meetings is quite a lot. So there has been, so one of the properties of the research group has always been that it has been very interactive and lots of discussion, so stimulating discussions. Next slide, I've tried to put this into a timeline. Yeah? And so starting from the beginning to the end, and you see below the main timeline, you see the RFCs and how long it did take to produce those RFCs. So if people say that production of RFCs gets slower and slower, this does not prove this. It just varies. And at the bottom, you see the timeline where the chairs have been helping the research group to stay on track. And on the top, you see working groups that were kind of spin-offs coming out of the Nmrg. Next slide, please. So slide 4. So 20 years ago, when the idea came along to write a charter for a research group, technology world looked slightly different. There was a lot of discussion about policy-based management that actually started in the 90s, mid-90s. Late 90s, we got COPS, and then a little bit later COPS PR, which many, well, there are not so many young people here, but if there would be young people here, they wouldn't know what it is. And along with COPS PR came another data modeling language, was called SPPI, which was kind of SMI v2, which was used for SNMP MIP modules to write PIP modules for COPS PR. And so that was kind of the scene. It was directory-enabled networks. Yeah, so John Strassner did directory-enabled networks. And then there was this big policy information model work done in cooperation with the DMTF. And so several RFCs published telling you how to write policy rules, event condition action rules, you know, what can you all put into an event condition and so forth. Now, at the same time, it was clear that SNMP itself isn't really doing enough. It was good for monitoring, but it wasn't doing enough. But somehow the IETF, the working groups working on SNMP, got so much stuck on security that they kind of kept stuck focusing on security, and they didn't really want to improve the technology. Researchers were running prototyping new management protocols that were running over HTTP, while the SNMP people said everything that's not running over UDP is broken by design. Nowadays we have RESTconf, but that kind of started some of the ideas here. People started talking about pushing data rather than pulling data. Well, today we call it telemetry, you know, different term for it. And there was lots of technology fragmentation because everybody was coming up with new technology, SOAP-based technology to ship management data embedded into HTML tags and stuff like that. Beep, something that the IETF created. At the same time, boxes were essentially very closed. Boxes, you had a CLI, and you could talk SNMP to it, and that was mostly it. And you were totally depending on what the vendor did put on the device, and you couldn't do much more. So flexibility was really limited by what could be done. So one of the first things we tried to break this up and try to evolve the existing technology. If you go to slide 5. So that's where people, just a few people were sitting together, and if you search the internet, you'll find even a photo from that time. We're sitting together. Bert Wein was at that time IETF AD responsible for network management. And so the idea came along, well, let's try to create a place where we can discuss these ideas without being constrained by the IETF frameworks and policies. Okay, so I wrote a proposal after the meeting. I did hand it in, and then Abel Weinrib, he was the IETF chair at that time, approved it, and so we got going in March 1999. Slide 6. So the first phase was really looking at management technology and what can we do to improve it. So the first one was dealing with the question that we now get multiple data models written in different languages. So do we have to duplicate all our data modeling work? That seems very costly to do. So could we actually go for a data modeling language that is able to be protocol independent? And so we define things once, and then we use that with multiple protocols. And the proposal that came out of the Nmrg was called SMI-NG, kind of trying to take SMI but allow more structured data, allow mappings to SNMP, to COPS PR, and whatever might come along in the future. This actually turned into a working group, but the working group did take a long time to write down a guidelines document. They couldn't even call it requirements. They couldn't even agree on using the term requirements. But afterwards, they couldn't agree on a solution. So that kind of disbanded at some point in time. The second goal was to actually look at the whole SNMP framework. So we wanted to have more structured data in there. We wanted to be more efficient, have data compression rather than, although BER is not that bad in terms of encoding efficiency, but you could squeeze out more. There was another working group coming along. It was called the Evolution of SNMP, and that was a really short working group until it found out that it doesn't have any agreement on anything. And so later we labeled that the end of SNMP working group. because afterwards really nothing has been done anymore in terms of SNP. That was the end of it. Once that has happened, there was always controversy about how SNP is used in the real world. And so as researchers, we said, well, if people claim this and people claim that, probably it's time to measure and collect data. So what we did is trying to write little programs that collect SNP data in such a way that you could convince people to share SNP traces, so they didn't contain any sensitive data or whatsoever. But it gave us enough insight to know what kind of protocol operations are used, how frequently, what's the typical communication pattern, and so on. And so we try to collect data from many different kinds of networks and try to do an analysis. And for that, we had to create a specification how to exchange the trace format and the metadata that is needed to understand where the data was coming from. That was essentially the first phase, and then at the end, it drifted a little bit more into measurement. We had meetings talking about net flow, IPFix came along, and so the attention moved a little bit away from, well, pure SNMP management technology to more measurement technology. Okay, and this is the point where I hand over to Laurent.
Yeah, thank you. Okay, so initially this second phase, I was expecting Lisandro, my previous co-chair, to cover that, because at the time of this second phase, I was only a young participant to the research group. So my recollection of the fact and the way I've maybe will express this is more from a participant point of view than really from a research group chair point of view. But anyway, I try to give you some useful information and food for thoughts on this second phase. We choose to name this second phase autonomic network management, essentially because in this phase, it came from, there were already several projects, architecture, initiatives that have studied autonomic networks, autonomic network management, architectures, all different techniques, closed control loops, for quite a number of years, with a large body of research results, multiple conferences and workshops. So this was already an established field in the research community, but there were some different sources and different active participants that converge on the need to sit together and try to define, identify some gaps, try to clarify some concept, and try also an approach with an eventual standardization of some of these of the elements required to have an autonomic network. So first goal, first step was to address some common understanding, as I said, gap analysis, also explore different set of use cases. This was supported by a series of meetings in the Nmrg, a bit more than a year and a half. We had several meetings, dedicated workshops, with inputs from research projects, essentially European research project, but also from industry players and other academic participants. The main aspect that were covered was, again, gap analysis, definition, and the different phases or aspects through use cases of the network phase, network configuration, bootstrapping, or secure bootstrapping, different aspect of SLA management, but also to try to reflect a bit on the lessons learned from the previous research that was already available, and on the real-world experiences, getting user operator feedback and requirement, but also on the one key element that although there were a lot of research results and very valid approaches, the industry adoption and the actual deployment of such technology was quite low for many years, and it was one of the challenges. Some of the outcome of this activity was well, two RFCs, 7575 and 7576. One is addressing the definition of the concept, with a kind of also at the end a proposal for a high-level architecture as a guideline. And the second one is covering the different gaps analysis in order to derive potential elements for the research group, but also what became later on the inputs to the Nmrg working group. So another outcome was creation, a UCAN both, I think in 2014, asking if it was relevant to create a working group, and then a few months later, creation of the Nmrg working group, which is still active. Nmrg working group, the scope is essentially on autonomic networking, protocols, a bit of architecture, and secure bootstrapping, so a very specific scope also. Still in this broad topic of autonomic network management, there have been more recently, we targeted Autonomics 3.0 in just to differentiate with this first goal, first phase of autonomic network management in Nmrg, not outside, but in Nmrg. Because when Nmrg was created, it somehow took with him a lot of the activity, a lot of also the contributors of on this topic, but it remains some gaps, some research direction that were not explored, and also to recognize that some elements in our environment were evolving. So, for instance, the increasing importance and also deployments of virtualization approaches, also programmable approaches, so NFV, SDN essentially. Also new application areas with currently 5G. Also the growing interest into IoT environment, IoT networks, and also a bit more, I would say differently packaged, but all the smart X example, like smart factory, smart city, smart transport, whatever you can think, that was trying to blend a kind of very domain-specific environment with communication technologies in various uses. Also, along those years, because we are talking about from 2013 to up to now, a really rising trend on what the industry called network automation. But so really the industry call it network automation, but if you look at what all the communication on this topic here is not only purely automation, it's really covering how to bring towards autonomous networks. I mean, we had a very interesting hot speaker talk on telemetry and all the challenges and the potential of this technology, and this is clearly in this trend of network automation, or to close the automation loop. So using learning mechanism, using decision making mechanism, or intelligence mechanism in order to really have more knowledge, more understanding of what's happening in the network, and trying to make the right decision to actuate on the network. And for the actuation also, all this aspect of using more flexible, more programmable systems across, I mean, end-to-end through the network, not only like a bit old-fashioned way of seeing a network with the different segments, but really end-to-end with all 4 gates cloud computing initiatives and all of such. So network automation, more like an industry approach, but which really uses a lot of the same techniques, principles, and in fact results that are in the field of autonomic networks. Also, new wave, and we have a specific discussion on that later in this session, but I label it like new way of AI and machine learning, and just make a reference to one of the idea of that is in the group. But what I mean with new wave is just that, I mean, it's not new that AI techniques have been used in networking environments. I mean, it's been 15 years or 20 years that those techniques exist and have been applied for solving different types of problems. But with the new wave, I'm referring to 5 years, 6 years ago, where this really neural network, and especially deep neural networks, were exploding and covering very different fields. And so there is really a new wave of techniques, but also of energy in order to investigate any kind of problem with those new, not new approaches, but new tools, I would say, which relates also to this aspect of intelligence in the autonomic networks.
Hi, Rick Taylor, Airbus. I'm the chair of the DTN working group, and I was trying to find a good moment to come to the mic. But as you're talking about autonomics, there's DTN is a working group all about store and forward systems. It comes out of deep space, so NASA and the usual players. So they independently, or we now within our working group, have independently done a lot of work over the last 5 years on what we're calling asynchronous management rather than autonomic, but it is autonomic. It's about how do you do event-driven management on a deeply disconnected network. So we've got a lot of work going on in the group at the moment, but we're really trying to reach out to people like the Nmrg and say, we don't know enough about management in depth. We know enough about our use cases, but we'd really like help from you guys because you know management and you know what worked in the past and where network management is going in the future. So if anyone is interested in what we're doing, and we have running code on live systems, for example, the International Space Station, there's components on there that are managed using asynchronous, policy-based condition event systems that back down now onto netconf-based systems. It's all really coming together now, but we need you plurals help to come and make sure that we're not making terrible mistakes. So bit of an advert there, but it does kind of fit in with your goals, but it's independently invented, unfortunately.
This is a good time, and thank you, Rick. I remember also, I think last meeting you also came to the mic to express
I keep trying to
work
ask for help.
DTN. I think this is something we should try to follow up. Maybe after the meeting, you and me can have a quick chat, but thinking about maybe either some joint discussion or joint meeting maybe at some point, or even through a kind of use case approach, if you can express, as you mentioned, you are really in your domain. So from management perspective, it can be seen as one application area or one use case, and maybe this could be a way to interact between the groups, so that through a use case document, we may also make some.
Absolutely. I mean, we've got architectural drafts which we can absolutely share and push through onto your mailing list and that kind of stuff. As with my chair hat on, what I don't want us to do is to go and invent an entirely separate and standardized way of doing 50% of the same things that either is coming out of the IETF or Anima or whatever, and just try and link all this up, just because we only have so many cycles. Let's not burn them independently.
Thanks. Also in this Autonomic 3.0 approach, to address some of the issue not addressed in goal 1 was to try to have better link with real-world concerns and operations. So try to involve or to get more aware of the requirement and needs from the operator community, especially trying to approach Nmrg and RIPE communities, but also to address or to get more knowledge from other emerging disciplines, if I can call it like them, like site reliability engineering or network reliability engineering, which are approaching the way of operating large-scale infrastructure in very different way. They don't call network management at all. They come with very different background, different techniques, and different, real life, really operational networks constraint and deployments. So I think we have to connect more with those communities and those way of doing things. And also effective deployment, try to, in this research that could be done in the research group to reason on the lack of wide-scale deployment. So this is maybe slowly changing, or not so slowly changing, with network automation, the industry trend, which I think we will have more adoption large scale. But still, really the core autonomic from the principles I've learned when I was a student, I think most of the architectural principles and some of the very basic techniques and approaches are not completely fully embedded into what we see today in networking environment. It's fragmented. It's not always the same. It's not uniform, but we are not there yet. So phase 3, I'm a bit more in my role here as a research group chair, because this is a bit the time where I joined Lisandro 3 years ago to co-animate the research group. So as I said, this second phase, most of the activity was drawn out with the creation of Anima in terms of fully coverage of topic. But still, we had some. We developed what we call the research agenda for Nmrg, and we wanted to address what kind of new topics, new research direction will be relevant for the research group. So we really invested time into. I mean, if you remember the previous 2 or 3 year sessions, inviting new topics, discussion, having side meetings, etc. So one of the key topic that is also was the topic of the previous session this week is on intent or intent-based networking. Just one way to phrase it a bit differently of what we see regularly is to see intent as a means for better usability and manageability of the networks. Because I think what I've seen, especially in IETF and maybe some other standardization organization, is that we are very much concerned with the format of the things and some mechanism or some protocols, but we are in the network management research group, and I think we should invest more also in understanding and putting at the start of the work the manageability aspects of those environments. And usability, if this is a bit maybe far-fetching for our research group, but all how people will actually use the system is should be a key concern. And so with intent, this is one approach to try to have better manageability, essentially through use of abstractions. So how not to go into every little details of how everything's are being coded, must be configured or monitored, but to have a useful abstractions in order to use the things at the right levels, and also the mechanism in order. The abstraction is not necessarily sufficient. You need also to have the mechanism in order to go from different abstractions level and to bind to the different functionality. Also, an important aspect in this manageability, how to achieve that, what I call transfer of knowledge and reasoning from human to machines. A key element here is that if you want to be successful with intent-based networking, it means that the machine, the system, needs to have different set of capabilities, cognitive capabilities, in order to, if I give him a high-level objective, a target or an intent, the way to derive it, it requires, I mean, quite powerful mechanism or techniques. Currently, we have ideas for some of them, but they are not really well defined and well integrated in a system that can really deliver that. But it's really important that what the human reasoning capability we have, which is very kind of simple or intuitive for us, it's completely not intuitive and simple for a machine. But the transfer of that is the key to make an intent-based system feasible and also workable. With intent-based networking, we also aim for providing a higher degree of flexibility and adaptation to the system. Because previously we were talking about policy-based approach. If you have a kind of imperative type of policy where you have condition action or even condition actions, essentially you are pre-thinking about all the situation in which your network can end up. And so you make these condition actions to say, if something's happened, I need to know it, and I need to plan what will be the reaction of my system. So you code beforehand all the possibility of our system. And then I will say it's just a matter of instantiating the policy, but then the system has quite zero flexibility. It's just reacting to what's happening. And if there is no rules to cover the situation, then it can raise an abnormal situation, and you will inject a new rule to cover this case. With intent-based networking, we want really to take a radical different approach, which is not necessarily new, and you have declarative type of policy, but the thing is that you tell the system an objective, but you don't prescribe, you don't code beforehand how the system will react to that. So you give flexibility, you give adaptation capability to the system to address the current situation and the objective in the best capable way. And also with intent-based networking, something that is not always in the discussion is to involve the user in a virtuous circle. I mean, if the user is providing is intense, I mean, in different formats, you need also to be, aware of what's happening. So We should find incentives way that the user can be in this control loop. The second field or second goal in this phase 3 is something that will be the topic of the next discussion: the use of AI techniques for network management. Again, this is not new, but there have been new techniques and capabilities. As I said, deep neural networks, graph neural networks, something that we have a specialist in the room here. Federated learning, so new way to approach existing techniques, but also very different ways or much more capable way of fetching the data. And so this data is available quite easily now. The very diverse types of data. Computing power, nothing to do with what we had 20 years ago. Storage capacity also, and data processing techniques. I'm thinking here about the MapReduce, Hadoop, Spark, and all those techniques to manipulate the data, not necessarily the machine learning types of techniques. But then there is a challenges. So because today there are really some mainstream use of machine learning techniques because they are successful in many other fields. And what I observe today is that in our networking field, we try to use whatever machine learning techniques as a hammer to solve any kind of network nail problems. So it works in, I would say, some cases, maybe most of the cases, but we have very few insight about how useful it is. I mean, if you need to spend, if you have a lot of requirements on the collection of the data, centralization of the data, the amount of energy, computing energy, also power, I mean, electrical energy you need to consume in order to run these machine learning systems, maybe sometimes it's clearly an overkill and it's not a sustainable approach for our networking environment. So we need to find alternatives. And I think the goal will be not to concentrate on a collection of use cases to solve any kind of networking problems with any kind of machine learning techniques. I don't think this is a good approach for a research group. But I think that we should reflect on, we should think on what could be the best way to integrate the AI and machine learning elements in or for the network, because also all these machine learning armor, they are not network specific, but network are very specific environment. It will be covered in the next presentation. And this is the last point, network specific AI ML. So just an outlook about, I'm not sure, we can have questions now, but maybe also at the end of the session. Future of network management. So networks and network management have changed a lot in 20 years. This is not news. But we have seen through the phases that somehow Nmrg managed to adapt to those changes over time, to address some of them with some RFC, some working group spin-off, and try to keep being an active and relevant research group. Maybe 20 years of longevity is due to that. Also, it's difficult today to predict what future networks will be. I mean, we can have some hints, we can have some projections, or some stuff may remain. So we could predict to some extent, but it's not an exact science. But what is necessary is to think about how the network are today. This something we can more have information, the near future, how they are designed, deployed, and operated. I was referring to SRE. For me, it's a completely way of understanding networking or computer networking environment. So not just saying the network have changed, but also the way to build network, to operate network, or what's a network element is completely different, completely disaggregated now. And based on those, on this knowledge, try to identify what are the key problems, the key challenges that will be relevant to address this network environment, and if we keep calling that, the management of those environments. And so the last point is network management. I make management very explicit here, is that are we still talking about management, because, or is it still the right approach? We are still having a network as a common denominator, but is management still something, a term that is speaking to people and still the right way to understand the relationship with network. This is just for as an open question. I think that's the last slide. So we can take questions now. As I say, we will also have a time at the end to discuss about the future, but if you want to have clarifications on the past or the current situation. Very good. So, Albert, it's your turn.
You want to use the clicker?
Okay. Give me a second to show the slide. Try to use the clicker. I'm not sure it works.
No.
Okay.
You change the slide, right?
Just give me a second.
Yeah,
I
sure.
try to do something. Try.
Okay. Yeah. Okay. Thank you. So I'm going to talk a little bit about artificial intelligence and machine learning applied to network management, and I think that the role, Laurent, correct me if I'm wrong, is to try to understand if the topics that I'm going to present they make sense to be adopted by this research group. And the way I'm going to do it is I'm going to do it through a use case. I'm not claiming that this is the use case or that this is the most relevant use case. I'm just saying that this is one of the potential use cases, because otherwise it's very difficult to frame the research topics without a specific example in mind. So in this case, it's let's say it's a management plane which is operated with artificial intelligence. I will say that this use case is quite common in the research, and we have two pieces. The first one is a piece which is a network model. So this is a box, a software box, that can be understood as a digital twin. So it's a digital representation of the real network infrastructure, and it is able to answer questions, very simple questions, such as, okay, if I have this traffic and I have this routing configuration, what will be the performance of my network? So it's kind of a simulator, right? A digital simulator of my network. And then we have a management module, which is taking advantage of this network model to operate the network, okay? And to decide which is the best configuration. Let's say that the user decides based on some kind of management language, okay, I want the lowest latency possible. Okay, then this module will use the network model, try to find which is the configuration that results in the lowest source destination delay or whatever performance metric you are willing to find, okay? So now let's talk a little bit about these two boxes. So the first box is a network model, as I was saying. It's a digital representation of the network. And it is a box that you can ask questions, okay? So I have this traffic, I have this routing configuration, and I have this topology. What will be the losses I will see in my network? So these actually, there are many ways to build this box. One of the ways is to use a neural network, okay? So you have a neural network, which is actually inside this box providing this answer. So this model is already trained, okay? And as I was saying, it can answer all kinds of questions regarding your network. Then you have the management module, which will use the network model, and it's operating the network, trying to find which is the best configuration to fill the goals of the user, of the administrator. There are many ways to implement this box. One way is to use classical algorithms, for instance, some sort of traffic engineering algorithm or shortest path routing. There are many ways to implement this box. Another way to do it is by also using artificial intelligence, in this case, reinforcement learning. That's a new approach. And the last item in my use case is the administrator setting up, which is the goal of the network, as Laurent was saying. You can say the intent. Okay, so this is some sort of language that the network module, that the management module understands, and that it will try to fulfill the administrator request by managing the network in such a way. Just as something which can be interesting is that if this module is implemented using deep reinforcement learning, then this language is just a reward function, which is very simple to express, and that will convert this reward into network primitives. But I think that this is a topic for another discussion. Okay, so this is my use case. As I was saying, let me insist, it's not the use case. It's just one use case to show all the other topics. So let's talk about what we need in order to build these kind of use cases, what we need to do in order to build this kind of boxes. So the first thing to build the network model is you need to represent the traffic, the configuration and the topology, and represent the performance and the cost. In a neural network, whenever you put an input parameter or you take an output parameter, you need a mathematical representation for this parameter. This is called feature engineering. And unless you represent this parameter in a meaningful way, the neural network won't be able to understand it. So the first thing you need to do in this kind of research is to say, okay, what is my input parameter? Traffic load. How I will represent the traffic mathematically. And that's the very first thing you need to do. This is called feature engineering. For instance, if you want to represent an IP address and you want to put an IP address as an input in a neural network, you cannot say that an IP address is just a number, because actually the IP address has a structure inside. And if you say that it's just a number, the neural network will not understand that there is a structure. Okay? So that's one of the first challenges you have in machine learning when you apply to these kind of scenarios. Actually, it's quite interesting because there are many parameters in networking which are graphs, right? The topology is a graph, routing can be understood as a graph, and many other important parameters of a network is a graph. Actually, the network is a graph. And actually, representing graphs inside neural networks is extremely complicated, extremely complicated. I don't want to get into all the details, but if you don't believe me, well, we can discuss it offline, or you can try it at home and you will see that it's very complicated. But you cannot put a graph into a neural network. And I will say that this has been one of the main challenges in machine learning applied to network for a long time. And there is one approach which is called graph embeddings, which does not work neither. Okay. So the answer to this is that there are many kind of neural networks. Okay. For instance, if you are working with images, you have one specific kind of neural network architecture that you need to use, which is called convolutional neural network. If you want to work with information that it is stored in sequence, for instance, like in a sentence, the information in a sentence is stored in the sequence of events, then you need another kind of neural network, which are called recurrent neural network. And these two neural networks are very, let's say, very popular. There is a lot of research, lots of money being put into that, because pretty much all the applications in computer vision, they work with convolutional neural networks, like self-driving cars and so on. So huge topic. Recurrent neural networks are used for text processing, translation, and so on. Huge topic, many money, also many research done into that. But until very recently, we didn't have a neural network which was specifically used to understand information which was stored in a graph. They are called graph neural networks, and you can see here there is a very recent publication, October 2018, from DeepMind and other authors proposing this new technology. And well, we tried it and we tried to apply it to a computer network. You have here the citation also. It's an open paper. You can see it, and it actually works. So we are able to learn to train a network module with one network, and then ask questions to this network module with from a different network with a different topology, which has never seen, and is able to provide accurate answers. But the question I think that it's relevant for the research group is, should this research group work on provided guidelines or mechanisms to represent common network parameters? Okay. There are many other questions. Maybe I think that I can go through all of them, and then at the end, okay, we will list them, all of them again. So, but this is the first question. The second question, and that's common to any machine learning application in the world, is accountability and explainability. Okay, so machine learning algorithms, neural networks, again, typically are pretty much black boxes that you train, you ship, and you hope for the best. And you don't know exactly what is happening inside, you don't understand it, and you don't know actually what it will work. You can train it a lot, and you can test it a lot, and you can have some sort of human emotional confidence on your work, but not a mathematical guarantee that this thing will always work. Because they operate probabilistically. And we, as a community, we're very used to have deterministic algorithms that we know exactly what they will do in pretty much all the scenarios. So this is a very disruptive and profound change for all of us that we have to decide if we want to accept or not. But that's a big deal in machine learning. So since we are not unique, this is a problem for many other applications. There are pretty much two approaches to solve this. The first one is called explainability. This is a technique to try to look inside your neural network and try to understand what's happening inside. So you have an understanding of why the neural network has taken a particular decision. I would say that this is quite a state of the art and quite a big research topic. But there is another approach, which is accountability, which is you use external boxes that will pre-process the actions from your neural network, and because you have a better knowledge, you're an expert on your computer network, you can decide if this action is correct or not. So you have some sort of accountability. So this box can work in helping you setting some operational bounds or limit the actions taken by the artificial intelligence. So this is pretty much your safeguard that you can use to when you're operating a computer network with a neural network. Okay, so then the question I'm suggesting to the research group is are you interested into working on guidelines, mechanisms, and architectures to support this kind of accountability? I think explainability is really a research topic, and it's really into machine learning, into artificial intelligence. The third one, databases and benchmarks. So there is no machine learning and neural networks without data. Okay, so that's you cannot do anything. Actually, the algorithms are cheaper than the data. And if you take a look to other well-established fields, such as computer vision, what they do is they have open data sets. For instance, ImageNet is a very well-known data set. It's a repository of images. Okay, so anyone, let's say that you want to learn something about neural networks for computer vision. So you go to this data set and you can start playing around. So this is education. Let's say that you want to do research on this field, on computer vision. Great, you have an open repository of images. You go there and you download all the repository, you train your neural network, and you try to see how good your neural network is. And even more importantly, you want to benchmark how good your new neural network is compared to the state of the art. Well, there are also well-established neural networks. For instance, AlexNet is one, which then you can say, look, I did my neural network in computer vision, and I'm comparing its performance to AlexNet, and I'm 20% better. So now pretty much everyone knows how good you are. And having a reference data set also helps us to see which neural network is better, because then we can compare your neural network with my neural network with the same data set, and we can see which one works better for a well-known and established data set. Now, we don't have this for computer networks. So students, and I'm having many emails from students, young people, that they are happy to work in computer networks. They are interested into machine learning, and they are willing to do something. There is no data set to start learning. Literally, there is nothing. So education is one factor, but I'm not focusing on education. I'm saying that even for education, that's an issue. Same for research, same for benchmark. So should we do something out of it? We have a very early attempt in this reference where we have a data set with some data for the students to start. Data comes from a simulator, which is not ideal, but this is what we can do with the resources we have. But should we try to push for a reference data set? There are many network dimensions. Which is the use case we are covering? Because with images, well, you can say, okay, those are images of things, and then that's something, right? But for us, what is the use case we're willing to do? This is my very personal suggestion. If we decide to go this path, I think that we should start by agreeing on one use case and then go for it, have one data set, and then start seeing how things evolve. This also involves some sort of cross-research group, working group activity, because we can go to other working groups, research groups, and try to define measurements, how to create this data set. Let's say that we decide one use case, we can go there and ask them, okay, how do you think we should build this use case if we had a real network? And then a benchmarking methodology for machine learning. So this is actually one slide showing how important all this data structure is whenever you want to apply it to a machine learning architecture. So then the question is, should the research group work on providing guidelines and help producing reference data sets and benchmarks? And I think that unless we agree on a use case, it doesn't make sense. So we should agree on a use case and then go for this. And then this is a more general fourth question, which is, well, there is no reference machine learning architecture. There are many, many use cases, and there are several documents describing use cases. Should we try to define a reference architecture? Should we try to understand how all these use cases, what they have in common, to try to define like canonical use cases? Should we try to define meta language for machine learning, for the data of machine learning? Well, I think that more or less you understand that it's quite easy to understand this area. So the question is, should this research group work in this kind of reference machine learning architectures for management and use cases? And the fifth one is for Jérôme. Thank you.
Thank you.
Yes, so the fifth, I think, topic or research question we were discussing in the group was related to what we call distributed artificial intelligence. So of course, Albert just introduced in the last slide that there is also some architectural related topic issue problems to address. And of course, if we're also thinking what are the differences when you want to apply AI to our domain, rather than, as you say, to images. And of course, we have to deal with networks that we think are, of course, really different than images, distributed system, in the sense also geographically distributed system, very critical, because we want to apply, in many cases, artificial intelligence on real time to change configuration and so on, and in a very short time. So we think that this is a very also different aspects, and that is different in our case and in other domain where AI is applied, even if of course it's not the only domain where with critical system where AI is applied. And naturally comes also the topic of if we think that AI is not run or executed or a decision taken in a single place, but more in let's say collaborative or distributed fashion. And so this comes with the idea if you have different, let's say, agents as usual, or they can collaborate for doing, let's say, AI in general, because there are also collaborative approaches for different things, but here is how we can take a better decision, accumulate decision for the different agent, knowing that they can have different, let's say, way of doing artificial intelligence on their own, completely dependent, even selfish, meaning that they even don't want to really collaborate, or can also work in collaborative ways. So there are different ways of distributed AI we can also try to pursue. Of course, you have multiple objectives, because if you think, of course, you have distributed system, we have different, let's say, entities over the systems. They want to do different things, configure different things for certain maybe application and so on. They have different objectives. They not necessarily pursue the same objective, and how you accommodate all these objectives to having something that is good for the majority, let's say. This is also a problem, and even for a single, let's say, entities that want to, let's say, fulfill different type of objective is very, very hard. Okay, sometimes in general you say that it's just an objective function that you put some weights, but it's not so easy sometimes. And of course, if you go for distributed AI, you find the same question as we had before. What are the requirements, maybe the requirements, the use case for that, the architectures that will support this and so on. So, yeah, so the distributed AI, maybe, Laurent, I will let you present in maybe the figure, because I'm not sure that I will present right.
Yes. Yeah, to give you a bit the inner story is that, so we had this topic in the agenda before the meeting, but we were not sure about what to say, what to present. So I gather a group of participants during the week, try to express in a very simple way what I would expect for this session. And I was very happy that they responded positively, made very good proposal, and mainly on the impression of Albert, very nice slide set. But we all contributed a bit from different point of view, so that's why sometimes we switch presenters because we are more comfortable with the different slides. So this is really work in progress. Some are maybe some not mature enough idea, but we would like to bring this as input to the discussion. So these two slides here is a bit my view about what I was mentioning before already, that for me, AI and machine learning as techniques and component is part of the landscape we have to do with. So we have AI elements and one. So I don't think this is the role of the research group to really work on the AI techniques themselves. I mean, we can have a good knowledge, good understanding, and even maybe try to reflect on the fact that those techniques need to be adapted or evolved. Like Albert was mentioning, graph neural networks is something that has been specifically designed to address graph, and so could be well applicated for network environments. But I don't think this is where we can have a real differentiator. But we are network management, so I was thinking about, also presented with the different other points, that we can somehow have an external framework surrounding the AI elements and provide the right interfaces, but also the mechanism, how an operator can use them, integrate them in his operational environment, and giving what I call features, not like ML features, but networking or management features, in the sense of being able to get some assessment on the performance. So we were talking about testing or benchmarking. So what is the way I can get performance information, testing information on my AI element? The aspect of accountability, explainability. I mean, I'm an operator. I deploy AI elements in my system, and there is an SLA violation. My customer investigates and says, "I want to know why," and it's my AI algorithm that made it. Yeah, but please give me more insight. So this is the kind of even if it's a very simple example, but accountability, I mean, this is, as Jérôme was mentioning, critical environments. We need to be able to make them, I mean, to have confidence in how they run. We will not be able to always go inside those AI elements because they will come as black boxes from many different vendors for different reasons. We don't want to go into that. But if we have this kind of external framework providing capabilities to operate them and to have knowledge and control on them, it changes a bit the picture. What I mentioned with robustness at the end is essentially robustness in terms of, you can think security. I mean, robustness to attacks, because AI systems can also have a very specific type of attack surface, but also robustness in the sense of data poisoning, or I mean, based on all the data are collected and clean and so on, to understand what will be the behavior of the AI elements in an operational network. So to also provide some level of confidence from the operator point of view on the robustness of such elements to different variation in the network. And then again, we are a network, so there will be multiple of those AI elements spread out in the network. Again, as Jérôme was mentioning, we can call them agents, but they can have very different goals. I mean, they will do different tasks in the network, and they will be designed for doing something, but they can be selfish, they can be non-comparative, they can be completely closed black box. So we will not always have the way to control them as we would like to be. I mean, the full flexibility, but then they will be deployed to address many functions across the network. And again, they will not come from a single vendor, so they will not be uniform in operation. They will not be uniform in many aspects. So, but they will play together, and they will be embedded into network, into a data center, and so on. So we have to manage the interplay between these AI elements from an operational point of view. And this is where maybe this could be an area to explore for the research group in this aspect of collections, interplay of AI elements. So not looking into the AI elements for AI elements, but capture their specificities and what we could put on top of them as a kind of overlay framework to integrate them better with the management systems, the operational systems, and help the operator to integrate them better. So this is the same template for all the topics. So what should the Nmrg work on defining distributed AI for network? So again, we will list the same points with the 5 topics at the end of this talk to raise the questions for the group. Albert, it's okay. Again. So this is this is the last slide. So now it's the time of open mic discussion. You have here the 5 topics, so covering what was part of the presentation, with maybe sometimes a bit variation to highlight some more specific aspect that should be covered for each of the topics. But we can go over the slides.
Rick Taylor, Airbus. Thank you, guys. That's a really great summary. I thought it was a really nice series of presentations. A couple of quick responses from myself. I think it was point number 2, which is not quite the same as slide number 2, which was about the accountability. Accountability and explainability. I can't remember the name of the speaker, but the question was, does the research group need to look in, are there special use cases for accountability and explainability that apply to AI/ML in network management? My question in response would be, is there a difference in accountability and explainability when AI/ML is applied to network management as compared to when AI is applied to computer vision in cars or wherever else, AI/ML of different flavors? If the answer is it's all about accountability and explainability, then going back to somebody else's point is we're not about research, we're not the AI research group, we're the network management research group. So unless there's a particular accountability that's required for network management, I would suggest no to 2. Sorry, can you go back to the list? I've got a couple of points. Just while you get there. One of my thoughts through all of that was we are the IETF and IETF here. What we understand is how the internet works and how we make the internet work going forwards, and we have historical knowledge. So what we can bring to network management and artificial intelligence is our expertise in networking and how the internet has been built and how it functions. Whether an agent is a human being or an AI or a machine learning system or whatever doesn't really make any difference. We know how to make different ISPs talk to each other across a gateway protocol. We know how to divide the complexity of managing the internet into small enough chunks that somehow it all seems to run, despite the fact governments may disagree over policies and corporations may disagree over who's going to make the most money out of it. So I think some of the policies when it comes to distributed AI, so I'm jumping to sort of point 5, I think we know roughly how to do that. I think we have a pretty good idea of best practice. There may need to be some update or some review of current best practice using humans to see how that maps to using AIs. But I would suggest that an AI is really just another example of an agent who is making independent decisions, but somehow that decision has to work as part of the greater good, or to maximize benefit for the entire system, if you want to be AI/ML about it. Yeah, I'll shut up, but those are my key points.
Albert, you wanted to respond, or?
Yeah, just to the first question you made, I don't think that there is any difference between accountability and explainability for AI in networks compared to other areas. And the reason is that you may have an agent operating an infrastructure, which can be a car or a network. And the actions that it will take, well, we want them to be accountable and explainable.
I agree with you as well. Sorry, it's Rick again. In which case, I think there is so much work for the research group to do here that I think, we could waste a lot of cycles on. So I suggest that that's not a primary.
Yeah, so commenting, I don't know, Sabine, you want to comment also on those points or not? Because I would just like to respond to this question of accountability as a participant. I agree on the not to go there for effort reasons and fact that something existing, I might leave it open for one dimension, is that it's not that we should work on explainability, accountability as being specific for networks, but if the interfaces are not there, we could identify what's specific. I mean, how to do accountability may be generic, but where to plug in a network, what metrics or data to collect that are specific, and how the network operator can use that. This is something we can provide, like an architecture or maybe the right interfaces, which will be different from finance, from health, from whatever, because this is not the same technology. But this will be, for me, the only area where potentially we can try to investigate something, but I'm not prescribing anything into that space.
In which case, I absolutely agree. Guidelines, informational reference material, absolutely. Spending time and effort developing new and novel systems to do accountability in neural networks designed for networking, no, not convinced.
Hello, this is Sabine from Nokia. I rather have a question related to the slides about distributed AI. So that raised a question. So actually, distributed AI is the very point of potential difficulty, because that means a network is not one single topology, is not one single layer. It's a jungle. It's an ontology or whatever you call it. So I think the big challenge would be to, if there is to be to define guidelines, the first thing we want to have, supposing we are not scared about the idea of a system that takes probabilistic decisions, is to make sure all these AIs, for example, that are related, working on top of one part of the network or one part of the aspect, we should make sure they take harmonized decision. So how to build a, I don't know, mechanisms or framework that ensure that at least the decisions that these systems take are understandable among each other, assuming they are each the correct decision, which would mean how do we ensure that they also have a harmonized, when I say harmonized, I mean a view of the network, of the state of the problem, of also a view of the decision making that they can share among each other, and that is understandable among each other. I think this would be a crucial work to do.
So Rick Taylor again, following up on that point, I think we already know how to do that with humans, and humans are probably less predictable than AI, maybe. So if we know how to do this with humans, and the IETF and the IRTF by extension kind of defined how to do that, then I think most of that work still exists. Yes, it might need refreshing. It might need some extra guideline documents, but I don't think that is something we should go, oh, let's reinvent the way we make the internet hang together in a different way because we want to use AI, rather than say, hey, we've got this tool called AI which will allow us to make probabilistic decisions within portions of the network, or perhaps to bind portions of the network together in a distributed or a top-down, or however we want to do it. I think we should start with where we are and look at what we've got before we tear it up and start again, because it'll be fun, but we won't actually achieve anything.
Okay. I will leave you the floor, Sabine, again, as a participant. Two elements of clarification. First, on the question, I mean, the comment from Sabine, in this slide with distributed AI, in fact, we are covering broadly two different elements, because distributed AI is something that is existing today, federated learning or different approaches to perform distributed AI. But one of the aspects described in this slide is that, and it may be not explicit, is you may have specific, I mean, it's the adequation between the fact that the network environment is by definition distributed and the fact that is it relevant to consider a way to distribute AI. Because sometimes data are only local, they are ephemeral, they can be relevant only for a certain period of time, and so certain approach of AI may not really fit well with things that can only be by definition distributed. So if this is confirmed to some extent, then we can go to the path of distributed AI, which raise other questions in terms of coordination or cooperation of the learning that can be made local, and it's, I mean, maybe you can transfer the model or transfer the learning, or I mean, all these aspects of different approaches to approach distributed AI. So this is one element I would like to clarify, and in this element of clarification, what I highlighted here is a bit different from this aspect of, I mean, kind of techniques of distributed AI. This is more the fact that my way of representing that AI elements will be spread everywhere in the network for different goals and different algorithms inside, etc. But we will have to integrate them in the operational processes of operator or internet, the internet, which you see it's distributed, but it's not really looking at how we do distributed AI. These elements are doesn't need to really be coordinated in order to share their learning. This is more like from integration from operational processes point of view. This just to make a clarification, because I think we, and Rick, you're mentioning rough consensus for AI elements. This is how we run the internet.
I'm just thinking of cool stuff that we could all spend many years happily working on, rather than it's that I know this is the IRTF, not the IETF, but there are really smart people here, so let's try and focus on achieving things.
And one just quick comment, and Sabine, I give you the floor, is I had a discussion also yesterday with the new IRTF chair, and so this topic was not at that stage yesterday. But one element we came in our discussion with Colin was we can identify very nice topics and really maybe try to go into this is really where we want to go. But there is another key point is, do we have the right competency in the group to address it? I'm not questioning if I think there are a lot of very smart people in IETF, but if we go into some directions, then we might need to go into other communities and try to get the right also expertise coming from that, in order that a bit like similarly to your initial comment on DTN, that you don't necessarily have the expertise and the knowledge of network management, so you don't want to reinvent obvious things. This is the same for us. I mean, we may say this is the right problem from Nmrg, but if we don't have the right skills from maybe specialized type of AI, then we may not be able to address the topic properly. That was my comment from a discussion with Colin. So please, Sabine, sorry it was a bit longer than planned.
Well, definitely, I do not intend to address this topic because this is not in my range of expertise. Maybe to clarify my first comment, I was rather meaning that what is necessary, it's like a, I don't know, information or data model or however we call it, to make sure that at some point there is a view of the network or of the problem that is able to interwork. We already have it because there's lots of stuff around, but if the answer is yes, that's great. But I still miss, I don't know, some tools that is able to say, okay, I have my big networks and there is a problem there. By the way, when I talk about distributed, it's not like the OSPF scheme. It's also at different level. So it's not the information or circulation is not among entities that do the same thing at the same level. It's also some of the entity are input to one another. So if there is a tool that says that is able to I don't know if it's translate, if I don't know how to do it. I mean, it's, I think maybe one of the requirements, if we make a requirement list to achieve this, that would be a tool that enables us to represent the network views with problems and decision in some translatable way. So it's not about okay. I'll stop here.
Yeah, this is Albert. I didn't want to make this point while I was presenting, since I was trying to be as objective as possible and trying to capture the discussion that we had. Now I can be a little bit more subjective, I guess. I have some experience on IETF and machine learning, and I know there is always a certain struggle on, okay, yeah, this is great, but how this will affect the protocols, interfaces, I don't know. I have no idea. What I think is that AI will transform the way we manage and operate networks. I'm fully convinced about that. I might be wrong, but if I'm right, this is a big thing. And that we cannot, just because we don't see a clear road map for IETF activity in this, just say no. That's a mistake. If this is going to transform our world, we have to be ready, and we have to understand it as much as possible. This brings to my second point. I think that here we have outstanding protocol and networking experts, at the best in the world. But maybe we don't have all the AI experts in the world. And this goes to my specific proposal. So I think that what we should be working on is try to understand how this will impact networking. Try to invite the artificial intelligence experts, try to see what people are doing, listen to them, and then try to see how this will have an impact on the network. But not the other way around. Not try to decide that's how this will have an impact, but invite them, see what they are doing, and then try to understand which will be the specific impact. Otherwise, we are blind.
Okay, my name is Yonggun Hong. Could you go to last page? Yeah, so I remember that from IETF 9.4 meeting, the NM network machine learning RG and IDNet have the similar ambition of this group, but they happen and disappeared. So nowadays, Nmrg is the only place to handle AI for network, AI for network management. So we also present several times the network management for RL or ML mechanism. So although it is difficult to make a quantum jump to other place, but it is very happy to receive feedback or receive the other person's opinion. What is your missing point and what is your other approach to solve your problem? It is good to us. So I strongly support this issue should be included in the Nmrg after that. But I would like to add a couple of comments regarding the question 1, providing guidelines or mechanism. Yes, if we have this guideline mechanism, very good, but you know, the network is a kind of different from the previous machine learning problem. That is not a problem of regulation. That is not a problem of the classification. It is more complex. And if we talk about network machine learning, do we have some consensus? What is the network scope, and what is the purpose of the network management to reduce cost or to reduce something? So I guess that we need more time to get some common consensus. What is our objective and what is our scope in this Nmrg? So if we have that consensus, I think that we make some progress of the AI for NM or AI for networks. Thank you.
Thank you, Jonathan. Hi, Al Swordman. So I wanted to echo that last
guy's comments over here about stuff. I sort of suspect that if you pointed existing AI software at our already existing networks and gave them the data feeds that they get to see from the routing protocols, they could probably already tell us something about how to manage the networks. I almost think that the class of things that AI systems do at the moment is entirely within their scope to understand graph databases and diagrams and stuff like that. And I wouldn't be surprised if they could run the networks better if they could do stuff. So it's not clear to me that they're not already out in front of us, and probably it would be an interesting, I think, science experiment to just let existing machine learning stuff loose on some of the networks, and they probably come back and tell us where we got problems and stuff like that. It's not obvious to me that we need to spend any time thinking about stuff for them. I'd like to see what the machines could already tell us about our existing networks and infrastructure. So I tend to say that we should get other people who are doing research in to come and tell us what they'd already know, because I'm guessing that we're more neophytes here than most people, and my sense is that they can find, unknown carcinomas in medical images. They could find stuff that we'd be surprised about quite trivially. So it's not clear that it's not our ignorance and their education, if that makes any sense.
Thank you. There are further comments? Or no? I see people hiding behind the pillars.
Jürgen Schönwelder. So one idea that I would find useful is, in particular, thinking about young people. I believe it would help if the networking community could define problems, one or two, where we're struggling with and where we think AI might help, but we can define it in such a way that people can pick it up, that we can provide the necessary data, and we kind of create a competition and let people try to find out good ways of solving that with different machine learning techniques. Think more like, we post a challenge and we invite the research community to sort it out.
Yeah, in fact, you are stealing my proposal. I was about to suggest that for the IM and NUMS conferences, that we propose a challenge, AI challenge at the beginning of the conference week to students and try to see what will be the outcome. But that's good that we have some similar ideas. Okay.
Yeah, Alberto Rodriguez. I want to follow up on that point because I think it's a really good point that we have the networking expertise here and we know what we want to do with the network, right? So maybe I'm sure that we have experts on machine learning as well in the room, probably. But even if we assume that as IETF we don't have the machine learning expertise, which I think we may have, what we certainly can do is expose our requirements for the machine learning community to address and to explore and whatnot. And even if we, as a research group, don't define any new interface or language or model, we certainly can define guidelines, we can define informational drafts that can help a lot to merge these two worlds together, right? So I think there's a lot of potential of what we can tell the world about what we expect for machine learning, right?
Rick Taylor again, following up on that, I'm agreeing with everyone in the line at the moment. The ability to give key, I'm repeating previous comments, but yes, if we can reach out to the AI community and say, here are our problems, and going back, my point was about data sets. I believe within the IETF and IRTF, we have these data sets. We just haven't told anyone about it. I imagine the BGP guys can give you 330,000 node graphs just off a command line. They can pull this out of their data. I seem to, about 15 years ago, I was doing a load of work on PTP systems, and I remember the computer science department in Washington State University had this thing called the King data set, which was a massive data set derived from DNS. So it's kind of a question to the room. Go back to your universities and your institutions. I think you have these data sets, but it might be worth the Nmrg trying to collect them and host them and advertise them.
Hi, this is Sharon from Nexar. I'm here mostly to hear Albert, but I have some background in network management. Currently work in vehicle-to-vehicle network and machine vision. So I have a proposal for Albert and the lady here also. When we go look for something like a pothole or a jaywalker or a slowdown on an obstacle, a blockage, we first define what it is we're looking for. So something that you can do is just write a MIB for the network. What is it you want AI to find? And then you can train. And the second thing is when you want to train, you got to have a feature engineering. So these are two things that a generic AI won't be able to do for you.
So I think you're wrong because you mentioned the MIB. Here I'm talking only young now.
Okay.
I was kidding.
I mean, network-wide young for annotations.
You can make enemies.
Utilization, a lot of faults, things like that.
No, I mean, thank you very much for the comments. Something very, I took note about this one. Yeah, thank you. Other comments in the line? I think Colin is waiting for a few moments now.
Hi, Colin Perkins, IETF chair. I tend to think a lot of the value we have in the IETF is bringing together the various different communities, bringing together the researchers and the network operators, the engineers. I can certainly see value in bringing together people with who have AI expertise and people with network management expertise. And I can imagine there'll be interesting things that could come out of that. I think we would have to see both a set of interesting topics and interesting research directions and a community forming to show that we have something which can be a successful set of research in this direction. And I think that there could well be interesting things here, but we need the community as well as the topic.
Yeah. Joran, if you give me a second, just also because to react to Colin's late statement and the one-off point of Albert, something it was quite difficult and still difficult that we have tried to do with Lisandro is when you want to kind of attract people or go to people and tell them, look, we have some stuff. Do you have any proposal or ideas how to make it a bit efficient? I mean, because here in the room, we have a bit of a mix of people that are networking, some AI, some other fields. And so we have a bit of a mix. But if you want to have a bit more collection of the network requirements or network needs and present that to the other AI communities, to say largely, how can we make this happen? I mean, it's just not only by going to a ML conference that we will achieve that. And inviting them to come here, I mean, it's quite challenging to attract in the first time people that have no clear, I mean, incentives to be here. It's costly. It's not an academic conference, so it's really an open. I'm not only targeting to you, Albert, but if you have an idea, it will be welcome. Is that it's? I think it's quite challenging. I think it's maybe a very good initiative to start, but we already tried it, and it's challenging to really have a common ground for the two communities to meet.
So, Jürgen, I'm reading a message from Jabba, from Pedro Martinez Julia. He is at NICT, and he wrote, I'm wondering if we should talk about AI or just machine learning. From what I see here, it is reduced to some sort of prediction of behavior from processing data. It is not actually exploiting all AI methods, such as reasoning and planning. In case network management wants to exploit AI, I encourage to also consider these other methods, at least reasoning and planning, and research how they really affect network management.
Yeah, this is Albert. So I think that we should do the opposite. We should not go there and ask them about our requirements, but rather invite them here. And I will go back to the how to invite them and see what they are doing and how these kind of technologies will transform our world. Let me put a specific example. There is a very recent paper about some important researchers. I don't remember exactly the name of the researcher, but it is DRL for packet classification. So it's pretty much a complete new way to do packet classification for forwarding. Do we know if this is going to change the way we need to define protocols? This is very related to the talk we had yesterday on the deep dive. on the technical deep dive. So I don't know. Really, I don't know. I think it would be a great idea to invite them and they show us what they did, and then we understand how this will change protocol design. And this is a very specific example. If inviting them it's complex, then let's go where they meet. I think that we can collocate, there are plenty of AI workshops, AI for machine learning workshops and conferences right now. SIGCOMM has like 2 or 3 concurrent, so maybe collocating a research group meeting there and then inviting those people to present, and then let's discuss how whatever they are doing changes protocol design, network design, and so on.
Thank you, Albert.
Rick Taylor again. I think the Jabber question was really interesting because it ties this discussion about AI/ML into the intent and policy-based network management. Because I think the guy on Jabber made a very valid point, which is if you can define the intent of your network, then you can throw machine learning at the problem and say, I want a network like this. Go configure it, go manage it, go make it be that. So perhaps there's crossover between the two big topics of this meeting.
Yeah. Yeah, I also believe the point raised by Pedro is fully relevant, addressing machine reasoning and other parts of AI that are not machine learning. We had this point in our discussion earlier this week with the participants providing the slide sets. This was mentioned. I think it was also believed that as a first introduction, we didn't want it to open too much other things, and also from the people sitting around the table, we were not fully comfortable in in terms of knowledge about machine reasoning and other field of AI. So this is maybe for something to come later, but the valid comment. Thank you very much. Thank you for the discussion. We will now switch to the last point, last part of the agenda. So in this last part, there will be two sub-parts. One will be I give you some high-level research group information, which I think will be useful. But at the end, there is a bit more about the process for the evolution, and okay, it will be also open for you to comment more specifically on that. So the meetings planned for this year already been announced on the mailing list. I will provide updates as they come. But the very next meetings will be in April, the IEEE IM conference in Washington. So there will be 2 sessions there. It's quite different from the type of session we have in IETF weeks, because we try to insert ourselves in the program. So we have a very short 2 1-hour session. One will be for the kind of newcomer to try to educate and share, raise awareness of what is IETF, IETF, and network management in the IFIP and IEEE network management communities. Also to try to attract a bit the more younger researchers to this field. The second session will be a technical session, and the topic is not yet defined. In June, we will have so this is under preparation. We potentially an interim meeting, Santa Clara, Mountain View in the US. Some elements are still being discussed about the hosting and the exact date. So I will keep you updated on that. But again, this will be a kind of face-to-face interim. I know it could be challenging for people to attend, but we have a set of participants that are based there, and we would like to take this opportunity. If you manage to come, it will be great. Don't have any clue about potential support for remote participation. To the best extent, we will try to make it happen, but this is not something under my control yet. Next, more kind of regular meeting will be in the next IETF in Montreal in July, potentially regular session, 1 or multiple, depending on our need. Also, potentially try to repeat what we had last year with a kind of half-day or 1-day type of technical meeting workshop hosted by one of the local universities, or during the IETF week, depending a bit of how it can work. October, this is also under preparation, discussion with active participants from University of Bologna, Nmrg workshop, again, kind of interim, physical interim, where we would like to explore a bit more practical aspects, especially on the topic of intent-based networking, with potentially simulated environments or lab environment, where we would like to start trying to implement first aspects and go a bit more beyond the paper or the theoretical aspect and try to play with some things there. And this could be also a kind of a warm-up for some project to a bit longer term to participate in hackathon in IETF on this IBN topic once we have a bit more experiences and results to work with. Potentially also November IETF 106 in Singapore, so a bit farther, but this is a bit our usual plan. Something we are putting also in place, monthly virtual meetings. The next one will be in April. The doodle poll is closed, and I will announce the date very soon. And there can be also some virtual meeting for specific topics on a per need basis. Just ask me and we will support. An announcement, so there will be Apply Networking Research Workshop 2019, which will be in July during the IETF week. If it's like last year, it will be on the Monday. There will be no research group scheduled on Monday, so to come for the participation of this workshop. The call for paper is out. One of the topics is on new approaches to network management, operation and control, but some other topics are also related. Submit your ideas. The deadline is feasible. You have different forms of papers, short papers or a bit longer paper. I think it would be good to have some participation from network management. So again, submit your ideas. If you want to discuss more at the group level, you can also put me in the loop and I try to see if there are common opportunities. But it will be nice to participate to this workshop. Research group information, so Colin had to leave, but I discussed with him yesterday about the new co-chair. We found a way and cleared the situation. So the new co-chair will be announced in a few weeks, depending a bit how we manage to get interviews with the candidates. But this will be, resolved very soon. Also, anticipating a bit on the official email I will send about that, but I reached out to the group to have secretaries appointed because as we are going into more rechartering, more regular meetings, and wanting to ramp up on the support of the research group to the activities, we believe that it was necessary to have also some people in support. We received several candidacy, and I selected Jefferson Campos Nobre and Pedro Martinez Julia in their roles. Why two secretaries? Essentially because we are operating worldwide, and since we will have also virtual meetings in different time zones, it will be essential to provide supports for those meetings and also allow for potential physical participation to the meetings of those secretaries, which are already active participants of the research group. So thank you thank you to them for standing up, and good luck for their mission and to cope with the research group chair. This is the research agenda I already presented several times, covering the currently defined 3 topics of the group. So we covered 2 of them today, and 1 in a session earlier this week. So this is to be refined, but currently this is situation. Number of documents for the research group. We have some individual documents, no research group documents. So currently, so a number of them that are related or not to the research agenda. This is absolutely not an issue. Some are new proposals, some are renewed proposal. And this is part of Nmrg evolution discussion, because at some point we will have to clarify very specific, products we would like to have for the research group, and so documents and milestones, and or to adopt them as research group documents, especially for the topic on intent-based networking, which is a bit more mature. On this topic of intent-based, this was presented in the last session, but once it's to make heads up for the people that were not there. We have our current work plan with 3 main elements: how to call stuff, how to express intent, how to realize intent-based system, and potentially new items. So this is still valid, but the update could cover other aspects such as clarifying the problem statement, the scope of investigation of the research group on intent base, because this can be a bit big. Also clarifying and documenting design challenges and goals, concept and definition, the time, intent at design on runtime or both, impact of the approaches using CI/CD, interoperability between intent-based systems, based on the presentation from Jeff, the aspect of continuous validation of intent and intent-based analytics, but also something I think is very important for us to go a bit more into the space of kind of evaluation of the concept, validating, having quantifying elements to validate if the intent-based topic is better than others, how it's working, and provide a bit of scientific way of demonstrating things. So a bit more experimental evaluation-based research. Something we will need to clarify very soon, this will be in the agenda of the next virtual meeting, deliverable milestone and criteria for research group adoption on the IBN topic, to clarify the set of documents we would like to produce, in which form, and to set some milestone in terms of adoption, next meeting, 2 meetings, to know a bit the pace and our goals in realizing those objectives. So I will not cover the last part, just support, but with different forms for the research group. For the future of the group, this was presented also last time, some important question and principle I would like to remind. We are a research group, and it's important we are research and we are a group, not just a collection of individuals. So important in the evolution to clearly understand what's our shared goal, what's the collective outcome we want to deliver. And the discussion on the AI for network management was really illustrative of that. Who is the public? Which are our communities? I mean, who do we address? Is it just ourselves? Is it the IETF? Is it other research communities? Is it the operator community? So it's important to understand who is involved in order to define the right scope, the right beneficiaries, and what we need to deliver. Our approach and way of working, I think this is going quite well, but always can ask a question about exploring other approaches and or changing a bit the way we meet, the way we discuss together. At some point, and for some topic, it may be also more obvious, but what is the link with the IETF? At some point, it could be also a valid point to, depending on the maturity of some of our research, to try to, again, provide guidelines or be a bit more clear about potential standardization path that could come out from the research of the group. 2 elements, pluridisciplinarity and cross-fertilization. I really believe that the AI topic was obvious that we should try to benefit from really competency that comes from different backgrounds, different fields. One discussion I had with Colin was to make a charter update, so we will not have a full rechartering. The idea will be to reuse the current charter, which is generic and not so long, but to extend or update this first existing charter with to capture the current focus of what has been agreed as topics for the research group. So the current main topic is intent-based networking, and we have set of contributors, proposal for specific items of investigation. So this will be documented as one of the current focus of the research group, and also with milestones to deliver on that. This doesn't close the door to other topics, but as long as we don't have something that are a bit more concrete, a bit more tangible, it will not be part of the charter. So again, this topic of AI for NM, this is we have seen a lot of potential. If we continue like this, I am really convinced that we can extend the charter with that. But the way we concluded with Colin yesterday was to make things a bit more explicit on the charter for that. Something I would like to try, and maybe it correlates a bit with what Albert was proposing, to not fully covering that, but inviting talks for at future IETF meetings or maybe other location, but IETF meetings as the primary target to cover hot topics in network management. So to invite very different different backgrounds, different topics, but to try to trigger a discussion and see what will be the interest of the group on that. And AI could be one way to address it. I will submit to the mailing list a in-depth, which is like several questions, a survey to get your feedback, your opinion on a number of aspects of the research group, such as the charter, should we stop or continue, the research topics, the way we work, what should be improved, and etc. So I will think about some questions, and of course what I expect from you is to try to answer the survey, of course, but to come with some proposals, and also why you think those your answers should be. I mean, what's your motivation behind the answer? And that's all for this status of the research group. So I don't know how much time we have left. Not so much, I think 10 minutes. We still have some time for comments, opinions, proposal for this evolution of the research group. If some things are not clear, you can also ask for clarification now, or if whatever you would like to discuss. Okay, so we had a pretty good interaction for the AI network management session, so I think people are a bit tired now. Thank you very much for your time, for being here, and for all the very good inputs and feedback. We close the session now. We will provide the minutes as soon as possible, and so be ready for the next virtual meeting, which will be mid of April, something like this. Thank you very much. Goodbye. See you next time.